Hi ladies, this is Mrs. Blaufuss. This is lesson 1.4 and today we're talking about polygons. So we're going to define polygon and the rest of the terms below are terms related specifically to polygons. So to start off, let's define the term polygon. So we can define polygon. First of all, we're going to classify it by the number of sides, but in a polygon, it's a closed figure where exactly two segments meet to form a vertex. And again, we classify polygons by number of sides. So let's look here at these polygons. And in these polygons, we can see these are all listed as polygons, yes. So we can see that they are made up of segments. And two segments meet to form a vertex. It's a closed shape. All of these shapes have segments where the endpoints meet to form a vertex. I'm going to add this piece here to our definition because the segments have to meet at their endpoints to form a vertex. And again, we classify by the number of sides. So let's look at vertex. If our segments meet to form a vertex, we can define vertex as the point where two sides of a polygon meet. And again, they meet at their endpoints. So let's look at the shapes that are not polygons for a second. And let's decide why they are not polygons. So this shape right here, it's not a polygon because this point, which is where the segments meet, it does not meet at their endpoints. This is not a polygon because it's just a line. It's not a set of segments. It's not a closed figure. It's simply a line. Here's no polygon because that is not a segment. It is an arc. And again, here, although the shape is closed, the segments do not intersect at their endpoints. Therefore, it is not a polygon. So there's two ideas we're going to talk about with polygons. One is classifying polygons. And when we classify a polygon, we classify it by the number of sides. So here are some common polygons. For this class, you should for sure know everything up to octagon. So you should know that a polygon with 3 sides is a triangle, a polygon with 6 sides is a hexagon. You should know all of these terms. In this class, we won't really use nonagon, decagon. We won't use that very often. But if you do need it, you should be able to quickly reference it. And this chart is on page 50 of your textbook. So that's the Discovering Geometry textbook, page 50. You can find this exact chart in that book. But you need to memorize from sides 3 to 8 the names of those polygons, and that's their classification. So again, we classify polygons by the number of sides. Now, once we get past 12, we don't really have names for these polygons. We call it an n-gon. And n stands for the number of sides it has. So if we say some polygon with, I don't know, 25 sides, for example, like listed here, if we see a polygon with 25 sides, we just call it a 25-gon. That's it, just a 25-gon. We don't have a special name for it. It's just called a 25-gon. Now this next area here, and I'm just going to move this down a little bit so that we can tell it's different from classifying polygons. So again, we classify polygons by giving it one of these names, a triangle, a quadrilateral, a pentagon. That's its classification. Now, when we actually name polygons, we name a polygon based on how many, or based on its vertices. So we use consecutive angles or consecutive vertices or consecutive sides to actually name the polygon. And consecutive means adjacent or next to. Okay, that's what consecutive means. So if we're talking about consecutive angles, we're talking about the angles that are next to each other. So A's consecutive angle is B to C to D to E. So we're going to name polygons using consecutive angles. Now, it doesn't matter if you go, in this case, we go counterclockwise to name this polygon A, B, C, D, E. We could also name it going counterclockwise. So let's get orange. We could go counterclockwise here. Oh, that is counterclockwise. We could go clockwise this way. So we could name it also, if we start at E and go clockwise, we could call it EDCBA. Make that capital, EDCBA, because when we talk about points, we use capital letters. I could start really at any point and go any direction as long as I'm using consecutive angles, consecutive vertices. So I could start at D and go counterclockwise. So I could say DEABC. But notice that I'm following my consecutive vertices. Okay, I'm going all the way around, going in the same direction, and I'm following along the sides of the polygon. So I'm going to give you a minute to look at this, make a list of ways that are appropriate to name a polygon, and a list of ways that are not appropriate to name this polygon. So it's a pentagon, that's its classification, but now actually name it. So pause the video while you work, and then you can unpause for the solution. Okay, here are a list of appropriate names for this pentagon. We could go counterclockwise, A, B, C, D, E. We could go clockwise, E, D, C, B, A. Or we could start at a different point that's not A or E, and we could go, in this case, I went clockwise, but you could also go counterclockwise. So I went clockwise to get C, B, A, E, D. What you cannot do, so when you name polygons, remember you have to follow along the sides of the polygon. What you cannot do is name a polygon like you read from left to right, top to bottom. You cannot do that. So an example of something that would not work would be just the one I outlined, A, B, E, C, D. That does not work. D, E, A, C, B does not work because A and C are not consecutive vertices. Another one that wouldn't work would be D, B, A, E, C. That doesn't work because D and B are not consecutive vertices. Now, when we name a triangle, the nice thing about naming a triangle is that all of the vertices are consecutive. So as long as you hit each vertex once, you're going in order. So a few different ways I could name this triangle would be ABC, just like I outlined. I could start at C and go CBA, that's going clockwise. I could start at B if I wanted to. I could go BAC, or I could go BCA as well. Now, when you're naming a polygon, you're giving all the list of all vertices in consecutive order. But remember when you're naming an angle, you need, in some cases, you'll need 3 vertices and the center letter in your name represents the vertex of the angle. Okay, and then one more thing to highlight is naming a segment. Use only 2 points, and those should be the endpoints. Okay, so if I wanted to name segment CD, I would simply say segment CD. Okay, and then make sure that you put the segment sign above your 2 endpoints. Okay, so this should be review. Okay, these naming angles and naming segments should be review. So see Unit 1 if you need to refresh how to do that. I think it's 1.1 and 1.3. Okay, a couple new terms that we have. We're going to define diagonal. And a diagonal is a non-consecutive, or a segment, I should say, a segment connecting 2 non-consecutive vertices of a polygon. Okay, so you can see an example of that diagonal to the right. B and F, those are non-consecutive vertices. The diagonal is the segment that connects those 2. Okay, over here we can see a list of convex polygons. A convex polygon is defined as a polygon whose diagonals are inside the polygon. Okay, all diagonals are inside the polygon. Now here we can see an example of several concave polygons. Okay, the blue lines, those are the diagonals. So just by looking at this, see if you can come up with the definition of a concave polygon. It has to do with the diagonals. A concave polygon is a polygon where at least one diagonal falls outside of the polygon. So looking at the star, it's a polygon. Is it concave or convex? Remember, a concave polygon is where at least one diagonal is outside of the polygon. So this would be one diagonal. Okay, it connects 2 non-consecutive vertices. So in this case, it is a concave polygon. The next part of this lesson talks about polygons being congruent. If you hear those sweet little voices, those are Maggie and Cece in the background. Maybe they'll be quiet now, but all right, so we're talking about 2 polygons being congruent. They are congruent if, so remember if means if and only if. And this means if and only if. That means the conditional statement and its converse are both true. So 2 polygons are congruent if and only if all, or corresponding, I should say, corresponding sides and corresponding angles are congruent. So let's look and see what we mean by corresponding. So anytime you write polygons are congruent, you're saying the four vertices, in this case 4 because it's quadrilateral, you're naming the four vertices like you would name a polygon. So you're going in consecutive order, C to A to M to P. That defines that polygon. That's naming that polygon CAMP. Now over here, we're talking about the polygon S to I to T to E. That's the polygon site, or in this case, it's quadrilateral. So when we talk about corresponding sides and angles, so first let's look at angles. So corresponding angles, we're going to look at the four angles in the first polygon, C, A, M, and P. Those four angles correspond to the same order of the vertices in the second polygon, S to I to T to E. Okay, so angle C corresponds to angle C. Now, in order for these polygons to be congruent, the angles all have to be congruent. So is angle C, that's an arc with one tick mark, is that congruent to angle S? So here we can say that angle C is congruent to angle S because, again, single arc with one single tick mark and single arc with one single tick mark. Then let's look at angle M. On angle angle A, we have one single arc with two tick marks. And in I, we have a single arc with two tick marks. That means that those two are congruent. So angle A is congruent to angle I. So these are the corresponding angles. If we look at M and T, in order for the polygons to be congruent, the corresponding angles have to be congruent. So here, M is an arc with three tick marks, and T is an arc with three tick marks, so they're congruent. And then lastly, we have angle P and E. And we have an arc with four tick marks and an arc with four tick marks. So those two angles are congruent. Okay, so we now can determine, all right, all four corresponding angles are congruent. Based on the way the congruent statement is written, C, then A, then M, then P, and S, then I, then T, then E. Okay, so we're going in that specific order of those angles. Now we have to look at our four sides. So if we look at how we name our polygons, C to A to M to P, we have four sides of this quadrilateral. And so let's look at our corresponding sides. CA is a side, AM is the next side, MP is the third side, and PC is the fourth side. And of course, when we name sides, we use the segment marking. So make sure that you have that segment mark above each one of those sides. And then let's look at the sides that it corresponds to. So CA, the first two letters in the first polygon, and SI, the first two letters in the second polygon. And AM corresponds to IT, MP to TE, and PC to ES. And again, remember you're using your congruence markings because we're talking about segments in this case. Now, in order to determine whether or not they're congruent, we have to look at our polygon. Okay, let's look at how it's marked. CA, we can see has one tick mark, and SI has one tick mark. That means that it is congruent. AM has two tick marks right here, and IT has two tick marks. That means it's congruent. TE and MP both have three tick marks. That means they're congruent. And then lastly, PC and ES both have four tick marks, meaning they are congruent. Okay, so we know that camp is congruent to site because all corresponding angles and all corresponding sides are congruent. So if you look at these polygons, and on your note sheet, I think I have this rotated already, but if you look at these polygons and we want to name a polygon that's congruent to A, B, C, D, E, we have to pay attention to the order that it's written. It goes A to B. So let's find an angle that's congruent to A. So we're looking for an arc with 2 tick marks, and that angle is N. Then we have to find an angle that's congruent to B, and that's angle M. Then let's find an angle congruent to C. It's angle L is congruent to C. Angle Q is congruent to angle D. And lastly, angle E is congruent to angle P. Okay, so if we name this, we can go in the same order of congruent angles, N, M, L, Q, P, N, M, L, Q, P is congruent to A, B, C, D, E. We have to also make sure that the sides are congruent. Okay, so AB and NM, 1 tick mark. BC, I'll use a color. You can say BC to ML, it's 2 tick marks. LQ and CD, 3 tick marks. And ED to QP is 2 tick marks. And then lastly, PN and EA is 1 tick mark. Okay, so that NMLQP is congruent to ABCDE. You could also, on this specific one, you could also go by naming this NPQLM. In this case, that also works, and I'll let you match up the corresponding parts, but N and A are congruent, B and P, C and Q, B and L, E and M, and the corresponding segments are all congruent. So in this case, you could write 2 different congruent statements talking about the same 2 polygons. Let's look at this. Let's look at this next polygon right here, these 2 polygons. Let's determine whether or not they're congruent. I'm going to let you pause the video while you work, and then you can unpause for the solution. Now in this polygon, not all of the information is given, but I'm going to rotate this, and you can rotate it on your paper. You can draw a new figure if you'd like. You can rotate in your mind, but I'm going to rotate it so we can actually visually see it in the same orientation. Now we don't have each segment given, but based on the information we have, Cece is saying hello to everyone. Based on the information we have, we can already see that these 2 polygons are not congruent, because already we have to start with S and J. Okay, angle J is the only angle that's congruent to S. We don't know any of the other angles. Okay, and then but let's keep going. We don't know any of the other angles. We don't know they aren't congruent, but we don't know that they are. Okay, so we can't really determine congruence in this polygon, but we can easily give an example of why it's not congruent. Okay, so whether we start going J to H or J to K, a corresponding angle or a corresponding side to SW, which has 1 single tick mark. So a corresponding side to SW will either have to be JH or JK. And in both of these cases, they're not. congruent. I should say, JH has to be a corresponding side to either WS or it has to be a corresponding side to ST. And in either case, ST or WS, it is not congruent. Okay, so that is one way we can already say like, nope, polygons are not congruent because all corresponding sides and angles have to be congruent. Okay, so since JH has 2 tick marks, it's not congruent to ST and it's not congruent to WS. Therefore, the polygons are not congruent. Okay, and then we have just a couple terms left to define. The first is perimeter. We've defined perimeter before, but just to remind you all that it is distance. Okay, distance around a figure. And in perimeter, we sum all of the sides. Okay, so in this example, we're looking for perimeter. We're going to add all of these together. Make sure whenever you're working with units that you define your units. So in this case, our perimeter of the figure is 37 centimeters. We added up all of the sides. And then some special polygons that we're going to define, and we will learn properties of these polygons in later chapters, but just to define them, an equilateral, I think of it as like a ladder. The steps of the ladder are like our segments. An equilateral polygon is a polygon with all congruent sides. So you can see here, these are equilateral polygons. All of the sides are congruent. Here, some of these are not even polygons. This isn't even a polygon. Here we can see, although it has 2 sides that are congruent, 2 pairs of congruent sides. So it's a rectangle that has 2 pairs of congruent segments. Not all 4 of them are congruent. So an equilateral polygon might be a rhombus, or a square would be equilateral, but a rectangle is not equilateral. The next special set of polygons, and again, we'll define properties of these later, but equiangular. And these are polygons where all angles are congruent. Okay, so you can see the markings on these triangles. All 3 of those angles are marked congruent. In this rectangle, all 4 of the angles are marked congruent. And then the last is a regular polygon. And in a regular polygon, all sides are congruent and all angles. So here we can see all 4 sides have 2 tick marks, and all 4 angles have 1 arc with a single tick mark. These are not regular. Okay, all 4 angles are congruent, but here these sides have 2 tick marks and these sides have 1. So there was a lot of new vocab this lesson. So please remember to jot down any questions that you have and bring them to class, and we can address them next time I see you. Thank you.